Yeah, hello students. Today we'll discuss about a multi-threading topics, uh, some of the important questions related to your exam point of view. So today we'll discuss what is the definition of a multi-threading, uh, life cycle of a multi-thread, and how can you create a thread class, and what are the thread priorities. So what are the predefined thread methods? All these things we'll discuss in this class. So first of all, let us understand the definition of a multi-threading. The name itself has two different words in this. One is multi. Multi means multiple. Multiple threading. Threads. So what are the threads? Threads are called as a process. Called as a process. What type of process? The process which is a small portion of a process, that we call it as a sub-process. Okay, so if we are having a multiple sub-process to be executed simultaneously to perform a multiple task within the same application or a program, then it is called as a multi-threading. So now you can understand. I'm sharing a screen. Let us take an example. I'm sharing a screen. In the screen, you can see that there is a video recording is going on. That is video recording is one process. Okay, and I'm going to write something on this notepad. Write is one other process, and I'm able to choose a pen, different types of pen here. I'm able to choose the different types of pens. So this is also one process. Okay, so I'm able to record an audio and also video. So this is also a process. All these are running under one application. We are using all these process running on one application. That application here I am using for doing all these things is OBS application. Hope it is clear all of you. So that is how here these all process are independent process. So video recording is automatically done. Background, the video recording is going on, and I'm able to write it on the screen. I'm able to choose a pen. I'm able to share my audio. I'm able to share the screen. Sharing the screen I'm able to do. So all these multiple processes are executed under the single application. Then it is called as a multi-threading. So all this process will be called. So here this complete the number here, process 1, this is process 1, this is process 2, this is process 3 and 4. So all these are running under the main application, main process. Is that clear? So this subdivision of the process are called as threads, which can be independently executed. So when I'm using a video recording, you need not to depend upon the writing operation. When you're doing a writing operation, you need not to depend upon the pen operation. Or when I'm choosing a pen, you need not to depend upon the audio operation. So there is no interdependency between all these options when we are doing a particular type of a task to be completed. So there, each and every process, here we call it as a sub-process. These are all sub-process which are running under the main process. Then this is called as a multi-threading. So by this example, you can be able to understand how the threads are running. So here we can also call threads are called as a lightweight process. As I said that why it is lightweight process, because of subdivision, because we are making this as a subtask. So that's why it is called as a lightweight process. So this main process is a heavy process. Heavy process. Why it is a heavy process? Because this heavy process has internally how many processes to execute? 4 number of sub-processes. and each sub-process is called as a lightweight process. Each process is called as a lightweight process, and that is nothing but we call it as a thread. So hope you can understand with this simple example. So similarly, we have n number of applications where we can be using this type of multi-threading. What are those real-time applications? It can be video games. So you are very familiar about the video games. When you are opening any of the video game, you can see a character running. You can see some marks, score is, you can see the score that is um, independently it will be incrementing its value and decrementing its value. The character on the game can be accessed independently. There will be a background music playing to that, and so many like this, so many components can be used upon a single video game. So video game is one of the PUBG is one of the application. Under the PUBG you have so many internal operations subdivided into the process, and each process is executed independently. So this is how we can call it as a, so how do you design those type of process, or how do you do the type of programming? So those type of programmings can be done with the help of a concept called as multi-threading. So similarly, it can be used in multimedia graphics and animations. So hope it is all clear. So now till here, this is the introduction part. So let us move to the next one. Then how do you access the threads? So how do you create a thread? So before knowing that how do you create a thread, thread has a, it is a predefined class. Thread can be created in two ways. One is with a class, other one is with the help of an interface. So here java.lang.thread is a predefined class. So when you want to create any of the thread, your class should be under this thread class. Means thread should be a superclass, thread should be a superclass, and under that A is a class which you have created. This is my class. This is my class, user defined class. This is user defined class. This is a predefined class. Okay. So what you have supposed to do is, whatever the class you are defining, that should be a subclass of the thread class. So that is how we are supposed to write the threads, and threads are under the package called as a lang package. So lang package is a default package. So this is about the thread class. Coming to the runnable interface. So runnable interface, with the help of an interface, when you have a predefined interface, what you are supposed to do? We need to write an implementation class. Class A implements runnable. So you are supposed to write like this. This is what the class you have created. So if you have a thread predefined class, you should use a subclass. If you are using predefined runnable class, then you are supposed to create an implementation class. So, but in our syllabus, we have only, so this is not going to be discussed. So we are discussing only the what you can call it as the, we create a subclasses to the predefined thread class. So this is a method where we are going to use in our syllabus. So next, moving to the, before going to the code, let us understand what are the different states of the threads can be entered into. So thread is what we call it as a, thread is a process. Thread is a process. So what type of process? It is a small process that we call it as a sub-process. So thread is a sub-process. Clear? In this sub-process, we have, in this sub-process follows some states. So this is about the internal states when the program is saved and compiled internally. This, when it moves to the CPU. Before moving to the CPU, it enters into these many states. So what are those states? Let us understand. This is regarding how the system internally, the internal operation of thread. internal operation of a thread. So now, what are the different types of thread life cycle states? There are 5 states: new, newborn state, runnable state, running state, block state, and dead state. So now, whenever we create any of the threads, so how do you know that you have created a thread? So when we are creating an object, thread, T is equal to new thread bracket semicolon. So this is called as a new thread creation. New thread creation. So whenever you create a new thread, so this is called as a new thread. This T represents as a new thread. So whenever you create a new thread, automatically it moves to the new born state. Clear? From there, from the newborn state, it has to move to the runnable state. Runnable means what? Now, all the threads which you have created. Let us take an example. This is T1. Like this, you have created T2. Like this, you have created T3. So, these are 3 different threads created. So, these are going to be stored in a ready queue. So this is a queue, and this queue is going to hold all the, it is going to be stored T1, T2, T3. So like this, the threads are going to be created, and it is going to be stored in a ready queue. So how it moves to this queue, that is with the help of start method. Whenever we say T1 dot start, whenever we say T1 dot start, something like T1 dot start. So immediately it is going to store in a queue, ready queue. Similarly, T2 dot start, then it moves to the ready queue. T3 dot start, it moves to the ready queue. So with the help of these methods, it is moving to the ready queue. Ready queue, the name itself is carrying name ready to execute. It is moving to the, so execution will be taken part under the CPU. Execution will be taken part under the CPU. So once this T1 is scheduled to the CPU, once from the ready queue, it is going to be scheduled by the schedulers. Schedulers will be used for scheduling one by one threads to the CPU. Then it moves to the running state. Then it moves to the running state. But how it will move from T1 to the CPU? It has to have some instruction programmatically. T1 dot, sorry, when we are going to use the run method. So whenever we are using the start method, run method is going to be used. When we say T1 dot start, automatically the start internally runs the run method. So each start internally invokes the run method. So if I say T2 dot start, immediately this run method is it is accessed upon the T2 as you called with start with T2. This run will be used by the T2. If suppose T1 dot start, after that immediately you have used this run method, then this T1 is applicable on this run method to be executed. So this is how you can understand whether it is a T1 or a T2. So now T1 is stored, accepted by the CPU. So till here it is clear. First it starts the newborn state. Newborn state is done with the help of a, what is that? Object creation. So once the objects are created, it will be stored in the ready queue. From the ready queue, if the from the threads which has been created, it has to be moved to the ready queue with the help of a start method. T1 dot start. When we say T1 dot start, immediately the threads which you have created, that will be stored in the ready queue. From this, the ready queue, it is going to be scheduled by the, each and every thread is scheduled to the CPU. Once it is scheduled to the CPU with the help of the run method, so now the CPU is running accepted T1 and it is under the execution. So this is how we understood. If you have completed an execution, then it moves to the dead state. then it moves to the dead state. So this is how you understood. So newborn state, runnable. From runnable, it moves to the dead state. The dead state, how it can move? Again, we have a method called as a stop method. So here we have a start method, here we have a run method, here we have a stop method. So these are the things you need to understand. Next. So this is one flow of execution. Suppose we have so many internally, we have the other way of execution also. So what is the other way? Let us take an example. You have created T1, but I did not use T1 dot start. Just you created a thread, but you did not use a start method. So whenever you are not using any start method, it moves to the idle dead state. It moves to the dead state. Same thing. You are creating a thread and stored under the queue, but this is not scheduled and it is not going under the execution of the CPU. Then immediately this from T1, all the threads can be moved to the dead state. You can check from T1 to, instead of going to the running state, it can also move to the dead state. So next, coming to running state. Suppose T1 is in the ready queue and it has been allocated to the CPU and it is under the running state. So if it is positively executed in the execution and now it is moving to the dead state, that is end of the execution. So hope all the things are clear. So from newborn it can move to the dead state. Has it is not just created, but the thread has been created but it's not used. From this um, ready queue, the threads can be moved to the dead state, as when it is not getting its chance or when it is a T1 process uh, is waiting for a long time in the ready queue and just wanted to remove from the queue. If anything is for a waiting for a long period of time, then it will move into the dead state. Next, after that, it moves to the CPU with the help of a run method. So this from here also it moves to the dead state once the T1 thread has been completed its execution. So these are all different ways of how that it moves to the dead state. Apart from these states we have, so just now we are seeing the start method, run method, stop method. These are all methods which programmatically we use, and internally when we are using all these methods, internally these flow will be understood. So next, moving to, we have some other situations to be observed, that it is in the runnable, and when it is runnable, one method is yield method. So it is running with the help of a run method, and again it is yielding back the same thread back to the runnable state. Meaning is that when you have equal priority threads, T1, T2, T3 are created, and every thread, all the threads has the same privileges. It has the same preferences. So how it is going to be executed? So it has to be balanced by the all the threads. T1 for few seconds, T1 for few seconds under the CPU 1 milliseconds of time. Again it accepts 1 millisecond of time by the T2, T3 again 1 millisecond of time. So this is how all the three threads are sharing the CPU time equally. So how it is able to do with the help of yield method. So next, moving to running. In this running, you can understand it is under the CPU, and when it is under the CPU, sometimes programmatically, logically, we want some of the threads to be the pause mode. Pause without any action. Then we are going to use a sleep method. T1 is under the execution. Once if there is any condition met, if some, I'm just writing an example, if I is equal to 5, then sleep. Then we are saying that this function should be kept in an idle. So idle for how many milliseconds of time? It can accept only milliseconds of time, not more than that. So that is how the sleep method is going to be used. Okay, so when it is moved to the sleep state, so automatically from the running, it is moving to the locked state, because now the CPU has to release that thread, because we have encountered the interruption saying that I is equal to 5. Because it is reaching 5, you have to keep it as a sleep method, that is the blocked state. From the blocked state, again, it will be resumed back depending upon the time expires. So if suppose T1 thread has been executed and the T1 thread has 1 millisecond of time taken for the execution and it completes. Okay. So from the blocked state, it moves to the runnable state. Once the time is expired, it just moves to the runnable state. Next, we have one more method called as a suspend. Suspend, when it is suspend, if suppose T1 thread is having some 5 priority and T2 is having 6 priority, T3 is having 1 priority. Priorities are the numbers which is assigned to the threads to understand its privileges are the preferences to be given upon the threads to be executed. So now 561, let us take an example of highest priority or lowest priority, whichever the number is lower, that will have a highest priority. So among 5 and 561, 1 is the lowest number. So this will become as a highest priority. This is a max priority. This is a norm priority. This is a max priority. Clear? So depending upon these priorities, so if any of the thread is under the running and some other threads are waiting, we will do something like this. T1, now T2 and T3. Now let us understand T1 is having 1, T2 is having 6 and T3 is having 1. So T5 is having 5. Clear? So T1 is under the execution. T1 is under the execution, but when it is under the execution, it can see T2. So it just continues, and then when it is saying T3, which is having the lowest priority, it has to be given the CPU time has to be given to the thread. Next, once it is suspended, it moves to the blocked state. From the blocked state, it moves to the running state again, runnable state again with the type of resume. Clear all of you? So we have discussed about sleep, we have discussed about suspend, we have discussed about resume. And moreover, new thread, stop, all this things can be. Next, coming to the next method is about the wait method. So wait is saying that some instructions to the process, you just wait for the millisecond of time. You just wait for the millisecond of time. For what purpose he has to wait? Maybe because of some resources, unavailable of resources. Wait is used for unavailable of CPU or render so that is how the wait is going to be used for the, if CPU is not available, then it has to wait. If the printer is not available, it has to wait. So it cannot wait long time in the running state, it has to move to the blocked state. From the blocked state, it has to move to the runnable state to get its execution time again. So that is with the help of notify. So notify will be used once as it is waiting for the resources. Once the resources are available, then it is going to be moved to the runnable state. After executing from the runnable state, it moves to the running state, and from running state it completes the execution, then it moves to the ready state. These are the different states of the child, and we discuss the next.